Let's talk about your cosmic neighborhood. You know Earth and Mars, but what about Mercury, the little guy next to the Sun? For years, Mercury was dismissed as a scorched, boring rock. But it's actually one of the most bizarre and mysterious planets in our solar system. Mercury is the smallest planet, barely bigger than our moon, yet it has a gigantic iron core, over half its volume. Imagine a cherry with a massive pit and just a sliver of fruit. Why is it like this? And how does it have water ice at its poles despite being hot enough to melt lead? Its surface is strangely dark, possibly coated in graphite, like a world dusted in pencil lead. Mercury's chemical makeup is all wrong for its location. It has elements that should have boiled away long ago. It's as if the planet doesn't belong where it is, like a polar bear in the Sahara. Mercury isn't just a hot rock, it's a cosmic crime scene, and we're the detectives. What violent events shaped this world? Was it born here, or did it migrate from elsewhere? The answers could rewrite our understanding of how planets form. Mercury is a key witness to the solar system's chaotic history. And now, it's finally starting to reveal its secrets. To solve Mercury's mysteries, we needed a closer look. Mariner 10 gave us a glimpse in the 1970s, but NASA's Messenger mission changed everything. From 2011 to 2015, Messenger orbited Mercury, sending back data that upended old ideas. The first shock: Mercury's surface is rich in volatile elements like potassium and sulfur, materials that should have been blasted away by the sun. This suggests Mercury didn't form where it is now. Messenger also mapped the North Pole and found water ice in permanently shadowed craters, ice on a planet hot enough to melt lead. These craters act as cosmic refrigerators, trapping ice for billions of years. Messenger also discovered strange, shallow depressions called hollows, features that seem to be forming right now as volatile materials sublimate and the ground collapses. Mercury is still geologically active. Messenger didn't just answer questions, it gave us a whole new list of mysteries. Its mission ended with a planned crash in 2015, but the clues it left behind changed everything. Now, we needed a new detective to dig deeper. The story of Mercury was just getting started, and the next chapter would be even more surprising. After Messenger, scientists wanted more answers. Enter BepiColombo, a joint mission from Europe and Japan, launched in 2018. It's actually two orbiters traveling together to Mercury, set to arrive in 2026. On its journey, BepiColombo has already sent back detailed images of Mercury's polar craters and volcanic plains. Once in orbit, the two spacecraft will split up. ESA's orbiter will map Mercury's surface and composition, while JAXA's MEO will study its magnetosphere. Together, they'll give us a 3D view of Mercury, from its iron core to its interaction with the solar wind. BepiColombo will test if Mercury is shrinking, investigate the mysterious hollows, and measure the water ice at the poles. It will also study Mercury's bizarre, offset magnetic field. The mission's goals are ambitious: to solve the biggest puzzles Messenger left behind. BepiColombo is the ultimate Mercury truth seeker. Scientists everywhere are waiting for the next chapter in this strange planet story. The main event is about to begin. Mercury's secrets are within reach, and we're ready to listen. You might have heard about the James Webb Mercury mystery, but here's the truth. The James Webb Space Telescope isn't looking at Mercury, and never will. The real star of the Mercury show is BepiColombo. Why can't Webb look at Mercury? It's simple. Mercury is too close to the sun. Webb's instruments must stay extremely cold to see faint heat from distant galaxies. Pointing it near the sun would destroy its sensitive sensors. Webb's mission is to look deep into space, not at our solar system's inner planets. The confusion comes from excitement about both missions. Webb is revolutionizing our view of exoplanets, while BepiColombo is about to revolutionize our understanding of Mercury. The real connection? What we learn from Mercury will help us interpret rocky exoplanets Webb discovers. Mercury is a key to understanding worlds across the galaxy. Each mission has its own role in the cosmic detective story. For Mercury, BepiColombo is the right tool for the job, and its discoveries will echo far beyond our solar system. Let's dive into one of Mercury's wildest puzzles: water ice on a planet hot enough to melt lead. Mercury's surface can reach 800 degrees Fahrenheit, 430 degrees Celsius, but its poles hide deep craters in permanent shadow. With almost no tilt, these crater floors never see sunlight and plunge to minus 290 degrees Fahrenheit, minus 180 degrees Celsius. These cold traps can preserve anything that lands there, including water. If a water-rich asteroid or comet hits Mercury, Most water vaporizes, but some drifts into these cold traps and freezes. Over eons, thick deposits of ice can build up. Messenger detected high concentrations of hydrogen in these craters, and radar from Earth showed bright patches, signs of water ice. BepiColombo's job is to measure the ice directly, determine its thickness, and analyze its chemistry. Was this water delivered by asteroids or comets? The answer could reveal how Earth got its own water. Mercury's icy paradox is a cosmic clue. Even in the hottest places, the universe finds ways to surprise us. The search for water on Mercury is about to get even more interesting, and it could change what we know about water in the solar system. Mercury's core is enormous, over half the planet's volume. The leading theory, Mercury was once much larger, but a massive impact stripped away most of its crust and mantle, leaving a dense core. What's more, this core is still partly molten, generating a global magnetic field. That's surprising for such a small planet, which should have cooled and solidified long ago. As the core cools and shrinks, the planet contracts, causing the crust to buckle and form giant cliffs and scarps. Messenger saw thousands of these planetary wrinkles, some hundreds of miles long. By studying them, BepiColombo can measure how much Mercury has shrunk over time. Mercury's magnetic field is also odd, offset toward the North Pole. No one knows why, but it could be a clue to the planet's violent past. JAXA's MEO orbiter will study this field in detail. By untangling Mercury's mighty lopsided heart, we'll learn about its dramatic history. The story of Mercury is written in its shrinking surface and magnetic mysteries, and the next discoveries are just around the corner. Mercury's heart still beats, and it has much to tell. Mercury's surface is a record of violence and change. Like the Moon, it's covered in craters, but look closer and you'll see features unique to Mercury. Messenger revealed vast volcanic plains, evidence of ancient massive lava flows. One standout is Nathaire Facula, the site of Mercury's largest volcanic explosion. These features show Mercury's volcanic past was more dynamic than we thought. But the story isn't just ancient. Messenger also found bright, shallow depressions called hollows, geologically young and possibly still forming. The leading idea, volatile rich minerals in the crust, sublimate in the sun's heat, causing the ground to collapse. BepiColombo will revisit these hollows to see if they're changing, proof of ongoing activity. Combined with evidence of planetary shrinking, Mercury is far from dead. Its surface is a canvas of ancient scars, tectonic wrinkles, and fresh hollows. BepiColombo will give us a front-row seat to this ongoing drama. Mercury's story is still being written, and we're about to witness the next chapter. Just when Mercury seems as strange as it can get, new theories push the limits. Some scientists think Mercury could hide vast fields of salt glaciers and even a thick layer of diamonds deep below its surface. The diamond idea comes from Mercury's graphite-rich crust, possibly formed from a primordial magma ocean. Over time, buried graphite could have turned into a shell of solid diamonds under immense pressure. If true, Mercury might be the most diamond-rich planet in the solar system. Then there's the salt glacier theory. Some bright deposits, once thought to be ice, could actually be flowing glaciers of salt. On Mercury, volatile-rich salt compounds could flow like glaciers do on Earth. These salty layers might create unique chemical environments below the surface. While life on Mercury sounds unlikely, these regions could have the ingredients for life energy, organic matter, and briny liquid water. We're not talking about little green men, but the possibility of habitable niches is fascinating. These wild ideas show how much we still have to learn. Mercury keeps challenging our imagination, and the best discoveries may still be ahead. So why care about Mercury, a small, hot, shrunken planet? Mercury is a cosmic Rosetta Stone for understanding how rocky planets form and evolve. It's the outlier that tests our theories and forces us to think bigger. Every planet tells a story. Earth's is about life, Mars's is about loss, and Mercury's is about survival and extremes. By piecing together Mercury's history, its giant impact, migration, and survival of volatiles, we learn about the chaos of planet formation. This knowledge is crucial as we discover thousands of exoplanets, many like Mercury, orbiting close to their stars. Studying Mercury helps us interpret these distant worlds. It's our local lab for understanding an entire class of planets. The quest to understand Mercury connects our past, present, and future. The past, the violent birth of the solar system, the present missions like BepiColombo, the future applying this knowledge to new worlds. Mercury, the swift messenger, has a big story to tell, and we're finally ready to listen. The universe is full of surprises. Mercury is one of its best.